Hi everyone, this is Roshni Tayal, a lead data scientist at Yum Brands and an educator. Welcome to the tutorial on data wrangling. Here we will embark upon a journey on how to uncover the hidden insights within a data and learn how to pre-process the data in a better way. Also, before we get started, do check out Scalar's masterclass by industry leading experts on Scalar's event page. Link is in the description. Let's get started. So let's start with the topic, which is data wrangling. So, what is data wrangling is the first question. So, you may also know the term data wrangling with the word data pre-processing, right? So, it is also known as data pre-processing, which refers to the process of cleaning, structuring the data, and transforming the raw data into a usable format for analysis, modeling, or any other downstream task which you are performing to take out the meaningful insights from it. So, data wrangling is basically the unsung hero or behind the scenes magician which transforms your raw data into meaningful insights. Right. So now the question is that why data wrangling matters? Why are we even studying about it? Why are we even talking about it? Right. So imagine you are given a mountain of unorganized, messy data, right? It is highly unreliable. It's filled with missing values. There are a lot of duplicates in it. There are a lot of inconsistencies and inaccuracies in it, which you can easily identify, right? How would you make sense out of that data? You need some tools to make some sense, right? So that you can provide some meaningful insights for the business. So, this is a critical step that ensures data used for analysis or machine learning is accurate, it's reliable, and appropriately formatted for the intended purpose. Right. So, proper data wrangling can lead to more meaningful insights and more robust models. So, it depends on you that how well you are performing data wrangling, how well you're cleaning your data and structurizing it to have more insights from it. Right. So, it plays a pivotal role in today's data driven world. Now we know this, right? Because this is highly essential for data analyst as well. So, in today's topic, we will talk about the following methods in pandas. First is ways to merge data frames. Second is joins. And the third is the very famous group by operations. Right. So there are multiple ways to merge data frames. Those all things we will be talking about in here. The joins concept, which is a very common question in interviews as well, and group by operation. Right. So let's start with the first topic, which is ways to merge data frames. Okay, so why are we talking about this topic? So let's say if you have multiple tables given to you, multiple data frames in terms of Python pandas given to you, how will you make sense out of them? How will you deal with them? How will you make it as one table? Right. So here we are studying about merging data frames. So there are two ways to merge data frames. First is concatenation and the other is merging. Okay. So let's talk about the concatenation first. So in order to continue with this tutorial, I have taken two libraries, which is pandas and the other is numpy. So pandas library is built on top of numpy library. Numpy library provides a lot of numerical abilities and pandas is built on top of the numpy library. So in order to import the libraries, we might know till now that we use the keyword import and then the library name, which is pandas or numpy or any other library that you want to use, and then followed by the keyword as, which helps us give an alias to the libraries, right? So for the pandas library, I'm using the alias pd as a shortcut to use it again and again, and for the numpy library it is np. So these are the very common aliases that we use for these libraries. If you want to have something else for these libraries, you can have it, you can definitely change them. Now, I I'm using the dataset which is cardekhodataset.csv. It is easily available on the Kaggle website. You can go and download it. Okay, so I'm using this dataset, and in order to use it in pandas, we need to read this dataset, right? So you can see that this is a CSV file. And how to read a CSV file? It's very easy. You can just use this method available in pandas module, which is read CSV. So I'm using the same because it's a CSV file. I'm using pd.read CSV. I'm providing the file path here, okay, and storing it into a variable which denotes data frame. DF is the short form for that. You can have any variable name over here. Okay, so I'm using it, and you see, once I read it, let me run this cell. Once I read it, I will see this data frame. Okay, so there is one problem here, and what is that? You see, I have the column names present in the data set, but along with it, I'm getting one unwanted column with the name unnamed, right? So this is the unwanted column. I do not want it, and my index column has got shifted, right? So in order to resolve this, I will just add one parameter, which is index col equal to 0. So I'm just setting the index column at the 0th position, and I will get rid of that unwanted column. Okay, so let's talk about this data set. As we can see, there are 13 columns in the data, and we have 15,411 rows in the data, right? So these are the data set. So how to list down the columns that we have, right? So you can just use df dot columns. This will list down all the columns that are there in the dataset. Okay, so I can see that there are 13 columns, but with these names: car name is there, brand is there, model, vehicle age, kilometer driven, seller type, fuel type, transmission type, so on and so forth. Okay, I want to see first few columns of this dataset, first few rows of this dataset. How will I see it? You can easily use the head method inside this pandas module, and you see, by default you will be able to see first 5 rows of the dataset. Okay, you can mention as many rows you want to see. If you will mention 10, you will get first 10 rows of the data. Okay, if you want to see the end part, the few rows from the end of the data, you can just mention the tail column. Okay, so by default, if I will not mention any number here, it will open up the last 5 rows of the data, which is this. You see, yeah, we can see the last 5 rows of the data. If you want more, definitely I can give any number that I want. Okay, so this is how you will see the first few rows and the last few rows of the data set. Okay, now let's move on. um, Once I print the data frame like this, I can easily see the shape of the data, but if you want to see it separately, we have the shape library, shape package with us. Sorry, yeah. So you see, it has 15,411 rows and 13 columns. So this is how you will get the shape in x comma y format. Okay, so now let's say I'm assuming that we might have duplicates in this data set. Okay, we might have a lot of duplicates in this data set, and I want to get rid of those duplicates. Okay, at a first glance, I'm not able to spot that which columns have duplicates or no. So what I will do is, I will just use the method drop duplicates. Definitely there were duplicates. Why I'm saying that? Because it is impacting the number of rows in my data. You see, initially we had 15,411 rows and now we are having 244 rows. 15,244 rows. Right. Definitely, so difference is there and we have got rid of the duplicate rows in here. Right. So I can store it into a new variable which is cardf, and I can do this way in order to just check the shape. You see, I'm getting 15,244 rows, and the number of columns is definitely intact because drop duplicates doesn't impact the columns, it impacts the rows. It will remove the duplicates, it will remove the identical rows in the data set. Okay, so now, next is to get unique values. How to get unique values of a column? So, let's say I can see there are a lot of car names here. I can see there are a lot of models in here, but I want to see unique model names, let's say. How will I do that? So, let's also check that out. Okay, so in order to check the unique, what I will do is I will just take, let's take brand. Yeah, dot unique. Okay, so there are these many unique values in the brand column in the data. Okay, similarly I can have the unique value for seller type. Let's take that out. I will just copy this line here and substitute this with the this. Okay, so I can see here are so many rows, but there are only three unique seller types: individual, dealer, and trust mark dealer. Okay, so these three unique seller types we have in the data. Okay, we can also take the unique of the fuel type. Fuel type, definitely petrol and diesel we might have. So let's move to transmission type. What are the unique transmission type? I will just copy the column name from here itself. Dot unique. I can see there are only two unique values for transmission type, which is manual and automatic. Okay, so this is how you check the unique values within a data frame column. Okay, now let's say you want to, now I have taken out the unique values in the brand column, but it's hard to count manually that how many unique values are there in this column, right? So I will not manually count it this one, two, three, four. I just want the number that how many unique values are there in this brand column. So how will I do that? So for that, we have another method with the name nUnique. This will help you get the number of unique values in a column. Okay, so you can also verify by counting from here. So there are 32 unique values in the column brand. Okay, these are easy to count, but this is not easy to count, right? So you can use this method. Okay, now let's come back to our topic, which was how to merge data frames, and we wanted to discuss about concatenation. So this is how you can just analyze the data set on a very basic version, right? Now, in order to um, merge the data frame through concatenation method, I need to split the data into multiple data frames, right? So I'm creating some subsets of the main data, which is car df. Now, how to create that? So in order to create that, what I will do is I will just do so what I'm doing over here is I'm taking the seller type column. We have seen that there are three unique values in this column, right? Individual, dealer, and trust mark dealer. So, and my target is to create the subsets from the main data, right? So I am taking this column and creating the subsets. So basically, I wanting to have three subsets of the main data, one with the value individual in seller type, the other with the value dealer in seller type. I will just copy this line, paste it here, replace this with dealer, and here I will replace this with trust mark dealer. Okay, so and save this into three variables, which is sailor 1, let's have sailor 2, and let's have sailor 3. Cool. So what I did over here is I have created subset of the data set, and this is how we have created. So using the indexing for the rows, I am just feeding the values for individuals. So I'm just trying to filter out those rows where I have the individual value for sailor type. Similarly for dealer, and similarly for trust mark dealer. Okay, so what this will do is wherever the value for sailor type is trust mark dealer, it will have the boolean value as true, right? And those rows will get filtered out. Okay, so this is there. Let us run this. Okay, so let me show you. I can see that the data set has got split. We have 5612 rows in sailor 1. We have 9459 rows in sailor 2, and similarly I can verify for the sailor 3 having 173 rows. Okay, so this is having very less number of rows, and I can verify my original number of rows in the data frame was 15,244, and I can verify that from here. I will just add up the number of rows and each of the subset that we have created over here, just to show that yes, we have created the subset successfully. Right? We are getting the required number. So yes, we have been able to split the data correctly. Now let's move forward. So talking about the concatenation, concatenation is not exactly a join. Okay, so join is a different concept and concatenation is a different concept, but it's a way to stack data frames or concatenate two data frames along a specific axis. So access over here plays a major role. Okay, so either it can be row wise concatenation or it can be column wise concatenation. Okay, so with this, many people also ask me about the concept of access. It's very confusing for them, so let's talk about it very briefly over here. So there are two types of concatenation, I said, right? One is the row wise, and the other is column wise concatenation. Okay, so this depends on what axis you specify. Okay, so like we have already said, if you specify axis equal to 0, it's vertical stacking. So I will help you imagine vertical stacking. So with the vertical stacking, you can imagine this, right? This is my T1 and this is my T2. This vertical stacking in terms of data frames, how would you imagine? Of course, we have rows along this and we have columns along this, right? So if we talk about vertical stacking, definitely we are talking about row wise stacking. So row one after another. And if we talk about horizontal stacking, definitely we are talking about the column wise stacking. So let's say you have 13 columns, you will be adding up the next 13 columns here, because table 1 has 13 columns, table 2 has 13 columns. So you will be stacking this way. Let's get back. So when you specify axis equal to 0, which is the default value, you are talking about the vertical stacking, which we just saw, which is row wise stacking. And if you mention axis equal to 1, we are talking about horizontal stacking, which is column wise uh, concatenation. Okay, now let's see that how this works in the actual data, the vertical stacking and the horizontal stacking, how this looks like. Okay, so in order to concatenate along an axis, what I will do is I will just create, I will just use pd.concat method under pandas module. Okay, and now I will just mention the subsets that we have created. Okay, so what are the subsets that we have created? We have created seller 1, we have created seller 2, and we have created seller 3. Okay, I'm not mentioning any axis over here. And now let's try to visualize the all seller. How does it looks like? Voila, we have been able to concat all the 3 data frames. I did not do anything, right? You just saw I just wrote one line using concat method. I just fed the subsets, the multiple data frames that we had, 1, 2, 3, and we are able to get 15,244 rows. Okay, either you mention axis or no. I have not mentioned, that means it has automatically taken the value as 0. Even if I feed axis equal to 0 here, it will give me the same result. Okay, so this is how we concatenate, which is row wise stacking or vertical stacking, row wise concatenation. Okay, so let's also see that how do we concatenate along a particular axis with the value axis equal to 1, which is side by side concatenation, right? So what I will do is I will copy this line, paste it here, and first I will show you the stacking for only 2 data frames, which is 1 and 2, and we will have axis equal to 1. Let us change the name, seller 1 2. I'm giving it the name as seller 1 2. Now let's visualize this seller 1 2. You see, something strange happened. We are getting 15,000 rows, 15,071 rows, and we are getting 26 columns, right? Like I told you, we had 13 columns in one data frame, and the other data frame also consisted of 13 columns, and that is why we are getting 26 columns. But now you see how bad we are getting the values, right? I will help you visualize this. So my data frame was ending at the column selling price. I Okay, selling price over here is not visible, but no issues. You see, vehicle age is there, and again we are having vehicle age, right? Which is, of course, you wouldn't want this. And you see, we are having values in here, but we are having non values in here. Okay. And you are you able to see that how it is being concatenated along the axis equal to 1? How this horizontal concatenation is working? We are having non values for all the rows for seller 1, and we are having non values for all the rows for seller 2 here. Okay, so if I just give you a very brief visualization for this, it is concatenating this way. This is T1, and everything over here is getting nan values for these number of rows that are there, and everything over here is getting nan values for these number of columns, for these 13 columns that we are having in T1. Okay, so this is definitely you wouldn't want when you are merging two data frames. Why I'm saying that? Because we are getting so many nan values, so many unwanted columns. Why we want to create duplicate for our columns? We are having 13 columns in our actual data frame, right? Why do we want uh, extra 13 columns? Duplicate 13 columns, I should say, in fact, with the nan values. Okay, so the number of rows is getting maintained here, but the number of columns are getting duplicated. So this is definitely not we want. So we take the default value over here, which is axis equal to 0, and we perform the vertical stacking, which is row wise concatenation that I'm referring to. Okay, so this was all about the concatenation. Now let's talk about the joins. So the concept of joins is actually very important because this is also the interviewer's favorite question, that what is inner join, how does inner join works, what is left join, how does left join works, how would you implement left join in Python using pandas. So all these type of questions are very famous in interviews. So let's understand. So this is a very crucial concept in the data wrangling as well. Okay, because this helps us in merging data frames. We have already seen the concatenation, but this also helps in merging the data frames, but through different join operations. So let's understand each and every join in detail. What is inner join, what is left join, right join, and outer join. So these are the four types of join that we will be studying, and this outer join is also called as full join or full outer join. Okay, so you will hear these names interchangeably, and try to relate it to outer join itself, which you see over here. So you see this diagram over here. We have table A, we have table B. So this is the Venn diagram. This is also called as Venn diagram, VENN. Okay, and we have two tables here, table A and table B. In inner join, we take the intersection of these two tables. Okay, now, let me explain you what intersection we are talking about and how this intersection looks like in the real table. Okay, try to understand the crux of the inner join. So, I'm explaining you this with a very simple data set, because if you understand the concept, you will be able to apply to this in the vast data set. So let's have two tables here. Table 1 has two columns, student ID and student name. And table 2 has three columns, department ID, department name, and student ID. Okay. So both the tables have a common column, which is student ID and student ID. Okay. So always understand that in the concept of joins, whenever you are trying to merge the data frames, there should be a common column between the two tables in order to merge them. Okay. If you want to apply join operation, there should be a common column. So I'm having a common column here, student ID in both the tables. Now I can see the probability of merging these two. But what join should I apply? Let's talk about inner join first. So inner join helps you get the common rows between the two tables, which we also saw as the intersection of the two tables. So it will give you the common rows between the two tables. Now, common row will be definitely decided on the basis of the common column, which is student ID. And this is a unique primary key column, which you know, right? So if I see these two tables at one glance, I can see that one is student ID 1 is there in both the tables, 3 is there in both the tables, 5 is also there in both the tables, 6 is not there, 7 is there. Okay. And similarly, in this table 2, 8 is not there in table 1 and 2 is not there in table 1. Okay. So if I do the inner join of these two tables, what will I get? I will get student ID, I will get name, I will get department ID, and I will get department. Okay, I will get these four columns in my resultant data set after merging. And of course, the common columns that we talked about. Student ID 1 is there in both the tables, so I will get it. It's Raj, and Raj studies in department ID D1, which is the maths department. Okay, now let's talk about the student ID 3. 3 is there in both the tables, so this will be there in my result as well. Name is Shashi. Department ID for Shashi is D6, and it's biology. Okay. Similarly, for student ID 5, we have this in both the tables, so I will take it. Okay, so Summer is there, and Summer studies in department 4, chemistry. Okay, similarly, 6 is not there. 6 is not a common row in both the tables, so I will ignore it. I will come to 7. 7 is there in both the tables, so I will get this. And some 7 is Abhishek. Abhishek studies in D5 department, which is the physics subject. Okay, so this is the result of my inner join, giving me the common rows between the two tables. Okay, now the question is that how do we apply it in pandas? Okay, so over here you see we are using inner join to merge these two data frames. And before coming on to merging the two data frames, let us create the two data frames with the name high kilometer driven cars and average mileage DF. So I will just create a data frame with this, I have already done this code. I will just copy it in order to save time. Okay, yeah, I will explain it to you. Okay, so what I am doing over here is I am grouping the car. I mean, I will explain you this group by concept later on, definitely. So over here, just understand that we are in a way creating a data frame where I am taking the mean value of mileage, right? So I am just filtering these two columns, which is brand and mileage. Okay. And the group by is on brand. So basically, we have this data frame, brand, and we have this mileage. Okay. So what I want is I want the average mileage that each of these brand has served. Okay, so we want to take the average mileage corresponding to these brand. So this is how I'm taking it. Average mileage df. I'm doing it like this. Dot mean dot reset index will give us the. Uh, so I will explain you all these things here. So over here, just understand that we are taking a data frame with the name average mileage df. Okay, so how this looks like. Yeah, you see. So Audi has traveled these much of average mileage. BMW has done this. So it's not ordered. You will see it's very unordered right now. Okay, so each and every brand has served these many average mileage. So this is my one table, table one, and this is the other table which I'm having with the name high kilometer driven cars. So over here I've created a data frame which consists of only petrol cars. Yeah, let me show you how this high kilometer driven cars looks like. So what I've done over here is I want to filter out those cars who has traveled greater than these many kilometers, 20,000 kilometers. Okay, and now you will see that in this high kilometer driven cars, you will see all those cars whose kilometer driven is of course greater than 20,000. You see, 20, greater than equal to 20,000. 20,000 is there, 60,000, 37,000. All the values are greater than this. Okay, so corresponding to this I've got 13,189 rows. Okay, so this is the other data frame that I'm taking, table 2, and this is my table 1, definitely with brand and average mileage. Now, what is the common column between these two tables for me? Table 1 you have seen, table 2 you have seen. What is the common column over here? Definitely the common column is the brand, right? Mileage is also there, but this is average mileage now. This is a new column which is average mileage. So the common column which is there between the two tables is brand. Okay, so now let's perform the inner join. Okay, so for performing join, we use the merge method given in pandas library. Okay, so this merge method, I have to feed the table names which I'm taking. So over here, the first table is high kilometer driven cars, which is this table 1, and the second table is average mileage df that you have created. Okay, now I need to mention that what type of join I want to perform. I'm mentioning inner join over here. Okay, we are talking about the inner join. Now it asks that which is the common column between the two tables that you want to join both the tables on. Okay, so here you see left on and right on. If you have the common column name between the two tables, you can just use on as well, like this. I can just use this. Okay. If you have the same name in both the tables for the common column. If you have different names in both the tables, you can use this. That in left table you have this name, in right table you have this name. You can mention it separately. It will join on those columns. Okay. So this is how you can do. Let's run any of these cells. I'm running this and let's see the table. Merged inner join df. So I can see there are 13,189 rows, which is same as the number of rows in high kilometer driven cars. Why? Because we have not filtered any of the brand names from here. We have taken all the brand names, right? That is why we are getting all the rows in here, 13,189. And you see that my tables have got merged. Average mileage have come here. We can match the value as well. We can verify the value as well in order to see that whether it is merging right or no. So wherever you see Maruti here as the brand, I can see the value as 22.425, which I want to verify from this table. Definitely, Maruti has the value as 22.425. So this is how merging happens. Okay, since we had the same number of rows in table 1, that's why we are not seeing the difference in the number of rows, but you can definitely take such example and then you can see the difference. Okay, now let's talk about left join. So this was all about inner join. Let's talk about left join. So in left join, it is also very easy. We have two tables, table A and table B. In table A, we will have all the rows plus the common rows between table A and table B in the result set. Okay, so I'm repeating again. So in left join, we will have all the rows of the left table plus the common rows of both table. Okay, so let's see this in our smaller, easier data set. Let's visualize this. Okay, so definitely I will have the same set of columns. So I'm just copying this here as well. Okay, now this is my left table, table 1, and this is my right table. Why I'm saying this as left and right? There is no logic over here. It's just that table 1 is on the left side, so this is my left table, or this is my table 1, and table 2 is on the right side. I'm just taking this as right table. Okay, I could have also taken table 2 as my left table and table 1 as my right table, however you feed it. Okay, right now in whichever order I've written, I'm taking that as left and right. So what happens in left join is we have all the rows of the left table plus the common rows from both the table. Okay, so irrespective of this, I will have all the rows of the left table. I've just copied pasted here. Now let's figure out the department ID and department for these three. Okay, so 135 we have already figured out, so I will just copy it. Okay, now we already know that student ID 6 is not there in table 2, right? Student ID 6 is not there in table 2, so we do not know the department ID and department information for them, so the value will come as null and null. Similarly, 7 we have, so we will just copy the value from here. So this is the result of left join. Okay, so this is left join. So for the rows that is not there in the right table, you will get the value as null for the columns from right table. Okay. And we have definitely the common columns in here. 1, 3, 5, and 7 is present in both the tables. That is why I'm getting the result as I'm getting all the values for them. Okay. So let's also add one new student with the name Sham. And yes, now this student is also not there in table 2, right? But since it is in left table, all the rows will come here, but I'm not able to find department ID and department in this table. That is why I will have the value as null and null. Okay, so this is the concept of left join. Similarly, on the similar note, we have right join. It's very similar to left join, what you have done in left join. So in left join, you prioritized left table and accordingly took the number of rows, right? In right join, you will prioritize the right table and take all the rows of the right table, and that definitely contains the common rows in both the tables as well. Okay, so now it's time to prioritize the right table. So my right join result will also have all the 4 columns. Okay, my right join will also have all the 4 columns, which is student ID, name, department ID. And as I said, we will prioritize this. Okay, and the student ID will also come up here. Okay, now I have, do I have the name for student ID 2? No, we do not have. Null. Okay, do we have the name for student ID 8? I will search in the left table. No, we do not have. 7, do we have? Yes, it's Abhishek. Similarly, for 531, we have Summer, we have Shashi, and we have Raj. Right, I will get the names. So these are the common columns that we had, right? And these are the columns which came exclusively from right table. So this is right join. Okay, so I am hoping that this left join and right join is very clear to you guys. So let me show it to you here. So you see in right join, the whole of right table will be there, which includes the common rows as well of both the tables, right? So let's see over here. How to use left join? Very similar to the inner join that we just used. pd.merge, the name of the 2 tables. So left table over here I have fed as the high kilometer driven cars table, and this is the second table which is average mileage df. Okay, how do I want to merge them? I want to merge them on left join basis. And again, I could have just used on keyword on parameter as well. I've just mentioned this left on and right on. Okay, so let's try to run this, and I will get the output. The number of rows are same, and definitely over here we are getting everything. That's why we can see this. Okay, so yeah, it's working exactly the same what you saw on the Excel sheet. So do not worry that how did it came or how not. Okay, because it is prioritizing the left table, which is high kilometer driven cars. So that's why it's little unordered than the first table that you saw. Similarly, for the right join, no reference, just the how parameter will contain the keyword as right, and left on and right on you can specify like this, or you can also use it like this. Okay, let's use like this. Okay, and let me run this, show it to you. Definitely we have got the result. Okay, we have got the result and we are getting the average mileage. Okay, now this was all about left join, right join, and inner join, but let's also talk about the outer join, which is also called as full join or full outer join. Okay, now this outer join basically is the mixture of left join and right join, to be very um, intuitive, to be very precise. Okay, so let me show the output to you. Definitely in the result set, I will have all the four columns. So I'm just copy pasting these columns. Now I made the statement that outer join will have all the rows you see here, all the rows of the left table, all the rows of the right table, and definitely it covers the common rows as well. So it will have everything. It's the mixture of left table, left join, and the right join. If you combine these two, you will get this full join. Okay, so let's see it over here, how this applies to our sample data. I will take everything corresponding to the left table first. Okay, and let's just try to have the department ID department for them, which is from the left table itself. Okay, now I have definitely missed for these two student IDs, which is exclusive on table 2, right table, right? So what I will do is I will also take these two students whose name is not there definitely, like we saw in right join. I will write them as null, and department ID and department name is given for them. So I will take them. This is outer join. Okay, what did we do here? We took all the rows of the left table, like left join, and tried to find out the department ID and department information for the students not there in table 1. We were not able to find, so null, null. And these two student IDs were exclusive to table 2. They were not there in table 1. That's why we were not able to find them, right? So department 1, department 4, these all information was there. So this is outer join, left join plus right join. Exclusive rows, all the exclusive rows of left table and all the exclusive rows of right table plus the common rows are already covered. Okay, so that's it. And the only difference over here in Python code is that you can mention the keyword as outer, and rest everything will be same. You will get the output. Okay, so we can already see there are some non values here for the few brand which is Ferrari, Maserati, Rolls Royce. Okay, so which might not be, whose information might not be there. So three new rows have been added up. So this is all about the join concept. Let's move on to talk about the concept of outliers. How to remove outliers? What are outliers? Okay. Now, so outliers are those unwanted data rows, unwanted values in our data set, which actually hinders our analysis. Okay, so these are the extreme values that you want to remove from the data set in order to drive meaningful insights from your data. Okay, so yeah, let's come to this removal of outliers, but let's understand this concept first. So, why I am talking about the outlier over here at random? Because outliers in our data set is a very common thing, right? We can definitely have, if we are dealing with a large amount of data, we can definitely have a lot of outliers, and they badly affect the mean and standard deviation of the data set. Okay, so it's very essential for us to remove them because it may lead to giving us the erroneous results. Okay, and you will also notice that the even after cleaning the data set, if you have not removed outliers, the most of the machine learning models will also not work well as expected. So it's very crucial for us to remove the outliers, and that is why I've included this section in the data wrangling. Okay, so there is one way. If I show this to you in a number line, we have the concept of quartiles. This is the, until here, let's say we have the 25% of data. This is the middle part, which we can call it as median. Okay, this is the 50% of data, and similarly we have quartile 2. This is quartile 3. This is quartile 2, which is at 75%. So this is called as interquartile range. Okay, this is called as interquartile range, and over here we have the boundaries. Okay, so this boundary has some value, which is q3 plus 1.5 times of this interquartile range I'm referring to as IQR. This IQR is basically quartile 3 minus quartile 1, okay, into IQR. And similarly over here we have Q1 minus 1.5 IQR. Okay, so any data points which is out of these boundaries are referred to as outliers. These data points which you see, which is out of the boundary, definitely outliers. Okay, so we want to remove these kind of data points from our data set. If so, you may also heard about the concept of box plots, which helps us analyze that what are the outliers and how we can, through box plots we can definitely visualize these outliers. So this is the box plot that I'm referring to. This is the boundary lines that I drew, 1.5, and similarly over here q1 minus 1.5 IQR, and this is q1, this is median, which is q2, this is q3, and this is IQR, q3 minus q1. Okay, any points lying over here will be the outlier. So similarly, we can do this in Python. I have already done it. Let me just copy the code in order to explain you. Okay, so we have this car df where we had just removed the duplicates and we had a few lesser rows than the original data. I'm creating a copy of this. You see, I'm using the copy method. I'm creating a copy of this data frame and saving it into a variable named df1. Over here, I just do not want to hinder this original variable that we created and just go back and run it again in order to get the value. Okay, so I'm taking two columns here, vehicle age and kilometer driven. Okay, now I'm iterating over the values of these two columns, df1 dot columns, and I'm taking the quantile value of these. Okay, you see, I'm taking the q1, which is 25% of the data. I'm also taking q3, which is 75% of the data. Okay, so quantile 1 and quantile 2 is there with us. Now I can also take out the IQR, which is interquartile range, Q3 minus Q1. And now we have this. Now I'm just applying the formula Q3 plus 1.5 into IQR. So those data points which is less than equal to the boundary and which is greater than this will get filtered out over here. Okay, and we have just we are just filtering those, you see. So all the points which is less than equal to which are lying inside the boundary, we are filtering them out. Similar here, which is inside the boundary, we are filtering them out. Okay, and doing the same. So you see the difference. Vehicle age is there, kilometer driven is there. Before removal of outliers, the dataset had these many rows, and after removal of outliers, the dataset now has 14,640 rows. So clearly, there were so many outlier values, right? So we cleared them up, and this clearance was on the basis of these two columns. You can definitely take more number of columns in order to remove them. I just took these two just to reduce the processing time and to explain you better. Okay, so yeah, this is how you remove the outliers. You basically try to take the boundary formula and filter the data points which is within the boundary. So yeah. Okay, let's start with our third part, which is group by operations. So in order to explain you group by with a smaller data set, let me just come to this Jamboard. Okay, so let's say we have a data set where we have these employee IDs and these employee are working on these departments. DS denotes data science, software engineering, data science, and DevOps department. Okay, and these are their salary. Okay, so let's say we want to analyze that which department earns the most. Okay, so what we will do is we will perform a group by operation. What group by will do is it will group the departments which are having similar values. It will make groups. Okay, so over here, if I do group by department, it will create a group of three because there are three unique values added up the salary for that person as well. So similarly over here, we have the scar df, right? Now we want to find the maximum mileage across different car brands. Okay, so we have different car brands we have already seen, but we want to have maximum mileage across them. That what is the maximum mileage that each of those car brands has given us. Okay, so what I'm doing is I'm doing group by on the column brand. Okay, and this particular column I'm taking as the max. So mileage dot max will give you the max of this column across these groups. Okay, so groups will be of OD will be one group. All the rows consisting of OD as value will have one group. So out of that, it will select the maximum value for the mileage. Okay, so maximum value we can see over here is 18.53. Likewise. Okay, I will explain you reset index. Let's just remove this. So this is maximum mileage cars data frame that I've created. Now you see that I ran this and I got such table. Okay. Once I apply this reset index, I'm getting the table in a proper format. Okay. So this reset index basically sets the index for the values and gives you the table in a proper data frame format. That's why we just use this. Okay, so this is how we are getting the mileage across the different. You can also verify this in a smaller data set. Right now, we have a lot of instances here. That's why we cannot verify this. But yes. Okay. Now, what I'm doing over here is I'm just renaming this mileage column with the name max mileage. So, how do you rename the columns here? So, we use the rename method. Okay. In bracket we mention the columns which we want to rename. Okay, so I'm renaming mileage into max mileage. Okay. Now what this in place equal to true does, so this in place equal to true will actually make the change in the variable itself. Okay, so let's say I am removing this and showing it to you. What if we do not apply this? I'm doing this. Okay, I can see that max mileage has come. But now again, when I will print this df, I will see that the change has not occurred. I can still see the name as mileage. I changed it to max mileage, but the change has not occurred yet. Okay, so the change will only occur in two instances: when I save this into a new variable, or if I save this in a new variable and I print this new variable, I will see that new variable has the max mileage column. Okay. Or what you can do is, in order to avoid this usage of new variable, you can use in place equal to true. It will make the change in this particular variable itself. Okay, now if you print this max mileage cars again, you will see that the change has taken place. Okay, so this is the use of max mileage. Now you can do several things. I took max, you can take median, you can take mean, whatever according to your wish. You can just take those. Okay, now I'm doing some other experiment. I'm trying to take those models which has run for greater number of years. Okay, I had these columns, right? Let me print this again so that you remember. I had car name, brand, model. We have model. Okay, we have vehicle age, kilometer driven, sailor type, fuel type, mileage, engine max power, seats, and selling price. Okay, so what I want to do is I want to analyze the models which have run for greater number of years. I mean, using this column vehicle age, I can say that, right, that this model X has run for so many years, has been running for last 5 years or 10 years. Okay, so this vehicle has run for 5 years on road. So this is what I want to analyze over here. So for that, what I'm doing is I'm grouping on brand. Okay, I could have also used model here. Let's use model. Okay. Now, this as index equal to false, I will show it to you how this is affecting our result. Let it be there for now. And we are taking this vehicle age dot max. Okay, so I'm taking the maximum year corresponding to a model. Okay. Now, let us run this. You see. Okay, so we have so and so model as well. So let's take brand only. We have some unwanted values in model. Okay, so you see that Audi, the maximum, the maximum time that Audi has run for a person is 12. So Audi has run for 12 years. BMW has been running for 25 years, right? So I can say that Maruti has run for the greatest number of years, right? So this is a long running car if anyone buys it. Okay, so this is the inference that we can get from this data. Now what I want to do is, since these values are quite unordered, I want to order these up, right? So I'm just using sort values by vehicle age. On what column do you want to sort these values? So I'm mentioning this vehicle age. In what order do you want it? I want it in descending order. That's why I'm setting ascending equal to false, and you see the result. You see, it has got ordered. So Maruti is on top with the least brand MG as 2 years. Okay. So yeah, if I remove as a index equal to false, okay, so we are ignoring the index as well here. Okay, so we are taking for that purpose. So you can definitely have more number of analysis around group by, and it serves a lot of purpose. We can take the maximum mileage, we can take the average mileage that a brand has served, we can take the models which has run for more number of kilometers, which model of a particular brand runs for more number of kilometers. You can come up with all that analysis from this data, right? So definitely this data wrangling is very helpful. So this was all about data wrangling. If you have any questions, please put that in the comment section. Hope you find this video informative. If yes, hit the like button, share and subscribe to Scalar's YouTube channel for more such content.